shoot-offs, as we were making PhotosynQ, we realized that there were some real-world applications that we may not have thought of initially going through the process, but then we realized that this is a really powerful tool that can really empower researchers in part of the world that don't have the ability to do real quality data-driven research. So we started working on a project in Malawi to empower researchers from both local universities and the government agricultural research and extension services. So the first problem, I don't know why the picture's not coming up. That's, uh-oh. That's gonna be boring. My pictures don't come up. All right, so the first thing is, why do we wanna do that? The main reason is because local scientists are much better positioned to solve local problems. They know the context of the problems, they know the context of the people that they're working with and what they're trying to achieve, as opposed to having someone from 10,000 miles away come and solve the problems. But local researchers are restricted from doing that, like I said, because generally a lot of the research institutions and universities don't have high quality labs, inadequate lab equipment, inability to get quality data. And then certain handheld instruments that might be useful, things like a SPAD meter that I'm sure people are familiar with, or a handheld NDVI meter. These things, they're either expensive, up to $2,500, or they only measure one parameter, and that parameter doesn't always correlate well with what's actually happening in the field. And the third thing is that there's not always a clear linkage between what's going on at a research station and what the farmer really needs in the field to be able to improve their quality of life. So we wanted to be able to bring the lab to the field. So the first thing we're doing, and I'm going to apologize, it looks like none of my pictures are going to come up. That's going to be really, really boring, is to collect previously unattainable data. This is the data that Dave was talking about, these direct measurements of crop physiological status, and this key metadata. Where was the measurement taken? What time was it taken? What was the temperature, relative humidity, the conditions when this measurement was taken? But then we can also help these research groups manage their data better. We have this digital data management tool that they can use to not only store it, visualize it, analyze it, but then also, yeah, that might be better. Just let me go through that way. At least people can see it. It'd be much less boring. I think so. It might be saved up locally. Okay. So well, while he's working on that, to also be able to share the results. One of the problems with research, and I remember when I was living in Malawi and doing research, I was with a guy from USAID, and he had put on a conference, and he had all these people coming to the conference and presenting their research, and there's this one guy who said, okay, in this district, I did this research with these treatments and these varieties, and I did this, and this is what I found. And there's a guy in the back of the room that said, I did that exact same thing, that exact same district with those exact same treatments 10 years ago, and I found the exact same thing. So we need to be able to get the results out there, share, make sure that what we're doing hasn't already been done. Let's get rid of some of that redundancy and that duplication and do stuff that really matters and keep things moving forward.
Okay. We have a technology development team. Does anyone know how to put it on this machine?
Yeah, just save it. Just save it. The whole thing is a PDF, and I can just scroll through. It should be saved on the desktop.
Oh, it's saved on my desktop.
Yeah, save it on your desktop. Yeah. I have no idea.
I'm making it better. You can tell.
No, I can scroll through the slides. The screen's big enough. Everyone will be able to see it. There, if you want to open that, it's on there. I don't know.
Now I understand. I thought this was the little drive, and in fact, that's the thing that connects your pointer.
Ah,
No wonder it
okay.
makes no sense at all.
All right, so go to Ag Bio Research Workshop. Final copies of documents. Yep, and then plenary talk. Plenary talk.
Boy, look at
Halfway down.
It's got a problem. There it is.
There it is.
All right, let's try from there. Sorry.
Yeah.
Is that where we are?
Yep, that's where we are.
That's a nice picture, too.
All right, can we try to go slideshow and see if it works?
Yeah, I'll do that.
All right, much better. Thanks, Dave. Okay, so, all right, so the last one was allowing researchers to conduct more appropriate research on smallholder farms. One of the outputs I'll show you from some of our research, from our research partners later on, will show that what happens on a research station doesn't really reflect what happens on a smallholder farm. So we need to be able to find a way, can we get researchers out onto the farms where they're taking real-world research, collecting real-world data, and then they can co-innovate with the farmers. It's not farmer here, researcher here. They can be together, and they can co-innovate, and they can change things. So we can do that, and we can also do multi-environmental trials. If you have a variety of a crop, let's look at it in 12 different places on smallholder farms and see what's actually happening. So what are we hoping will happen? What do we want these researchers to get? We want them to be able to create their own intelligent solutions. If they have a disease that is just in a small area, we want them to be able to come in, use PhotosynQ, collect data, and build their own algorithm so that they can predict when that disease is happening. Because a researcher in the capital city of Malawi might not care about some random disease in Mzuzu way up in the north. So we want the local researchers to be able to solve their own problems. And we also want to develop recommendations, empower researchers to come up with recommendations, crop recommendations, varieties, management, that really reflect the status of the crop, the farmer's resources, what's their soil like, how much labor do they have, how many financial resources do they have, what can they really do, and then also look at the climate. Put all these things in together, make sure that we can analyze them all together as a chunk. And then another hopeful outcome is this idea of creating a market for quality data. Really trying to have people want to get the data and build, and that could feed into entrepreneurship that I'll talk about in a little bit. So I'm going to tell you a little bit about what's been going on in Malawi in the last 18 months. First, we started in February 2015. Flew over, met with some researchers at the Lilongwe University of Agriculture and Natural Resources and Malawi's Department of Agricultural Research Services. We gave them some devices, we gave them some training, and we thought, this is going to be awesome, off you go. And they started taking a couple projects here in Chitedze in the central and an on-farm research site in southern Malawi. And they got some really interesting data. This is the first project. And here, just real briefly, here is the SPAD data from the station and the farm. And this is nitrogen, there should be an N there, fertilizer rate. And what you see is on this station and on the farm, how much nitrogen you had didn't really have an impact on your SPAD results. And then you come down to the research station, and how much fertilizer you put on the ground didn't really have an impact on what your yield was. But then when you go to a farm, all of a sudden there's very clear response curve that you can see on multiple treatments. These are no-till maize, intercropped with pigeon pea, with cowpea, no-till maize, in rotation with cowpea, just continuous no-till maize. It doesn't matter which treatment it was, there was this very clear response. You add fertilizer, you get more grain. That's not an incredibly earth-shattering revelation, but what is important here is that these two graphs, they don't look anything alike. What happened on the research station had nothing to do with what happened in the real world. But after that really exciting start, everything ground to a halt. What happened? We ran into a bunch of roadblocks in Malawi. The first one is, PhotosynQ is a web-based platform. You got to create your projects online. Then you've got to download it to your phone online and go out to the field and collect all the data. And in countries like Malawi that have poor internet access, people just had trouble getting it. It's like, oh, is it working? Is it not? I got to the field. Oh, I need to update it, but there's no internet for 30 kilometers. What am I going to do? I'm going to put it in a drawer. I would too. The next problem was, it was a new system. Completely different way of collecting data. Completely new data that a lot of people weren't familiar with. So they just didn't know how to go out and really collect quality data in the field. How am I supposed to walk through the field and take these measurements to make sure that I get the best interpretable data at the end of the day? They didn't know. And the last one is the availability of quality labor. In a place like Malawi, you have a large chunk of the population that's never had a cell phone. Now you're giving them a smartphone with an app. That's not always going to work. So in the United States, when we started this beta testing, we had this, this technical support online. Go to watch some YouTube videos, go to the website, type in, technical support forums, and you can go and we can interact. But that doesn't work for somebody 8,000 miles away who has poor internet capabilities, who it takes 15 minutes to buffer a 5-minute YouTube video. Nobody's going to watch. So we changed course and we realized that we needed to build local expertise. And we needed to make sure that there was somebody in Malawi who anybody could call, he would go, and he would know how to solve the problem. So we found ourselves Frank Mtombala, who's been an incredibly helpful person. Once we brought him on board, got him trained, and we told everybody that we were working with, hey, listen, there's this guy, he's right down the road, call him. His phone was ringing off the hook. Can you please come out? Can you help me figure out what I'm doing wrong? Why can't I get this to work? So he went out, he supported creating projects, analyzing data, troubleshooting any issues that came up. And he also started to help build and expand our networks. We have someone that anybody can call. Hey, this is a cool tool. Who do I talk to? Call Frank. And that was really helpful. And once we brought him on board, the amount of data we were collecting just exploded from 200 data points a month in Malawi to 2,000 data points a month. But that's only part of the advantage of having someone like Frank. The other one is that now we have a stronger link between the users out in the field and developers like Greg and Robert and Sebastian and software people. So they can say, hey, what's going on? I have a bug. They report it. They let us know what's going on. Your average everyday user isn't always the best at telling you what happened when there's a software bug. And anybody who used the app in the last year probably ran into a bug or two. So now we had this link. He could say, this is what people need in the field. This is what, when I talk to my people, all these different partners that we're working with in DARS and Luana and these universities, this is what would really help them collect data in the field. And then it also drives innovation and entrepreneurship. What we're hoping is, Frank started his own company. He doesn't work directly for us, he has his own company. Our goal is in a couple years, we step back and he uses PhotosynQ and the idea of providing quality data as a platform for him, for his own financial security going forward. And we hope that this won't happen with just him, but we hope this will happen with other people. In a country like Malawi, there's a lot of college-educated graduates who get out of college, they can't get a job. But they're intelligent, they know what they're doing. If you could get them a phone and then a device, and there was a demand for data, do you have people then that could be their own entrepreneurs and go out and say, I'll go collect data for you? Maybe you want an independent evaluator for a community seed system, and you want to be able to confirm that the quality of that seed is good. Here's someone, go out to this village, measure these plots, put it on the website. Now we can find out if it's good quality or not. So now I'm going to go through and I'm just going to talk about some of the partners we've been working with, a little bit about what they're doing with it. Not going to get too much into their results. But so first, we want to look at what Dave was talking about, this idea of how do genetics and management interact for phenotypes. So we have people who are working on looking how plant breeding and management interacts. They were looking at screening for drought tolerance in soybean, in sweet potato. They were looking at matching maize varieties with different fertilizer rates, with different ways of irrigating crops in the dry season. So what we see here is that, okay, again, we can start seeing what the response is between different fertilizer levels. We can see where people are in the field, what they did, where they did it. And we can start separating how these different irrigation schemes work and how it affects the crop production in these different areas. This is Esner Yohani. She's a plant breeder with the Department of Ag and Research Services. She wanted to separate performance phenotypes in the pigeon pea project that Dave was talking about earlier, and also in introduced sunflower. So here we go. Now we can see these 10 different lines of pigeon pea, and we can see how their photosynthesis is different, how their spat is different. It allows them to rate varieties, get a better idea of what's actually happening. Also here, get an idea, the red are the higher yielding plots, independent of variety. Blue are the lower yielding varieties. We can start seeing how this interaction between different photosynthetic parameters affects crop production. And that helps to develop indicators for these researchers going forward. They start to really know what to look for. Next year when they do this same project, they're knowing what to look for. We've started to build these analytics and these markers that we can work with people. We can also build a lot of capacity in the institution. This is at the Lilongwe University of Agriculture and Natural Resources. There's a big project with Washington State University. They want to introduce quinoa into Malawi as a health supplement because it's a high protein grain, much healthier than some of the other grains. So they have all these introduced varieties coming in, and they want to know which ones work. And it's not just Dr. Moses Malero seen here who's doing it. It's also graduate students, undergraduate students, other faculty. About 10 different people are doing some project on quinoa at Lilongwe University. And here's what we see. Here's a project where they looked at how quinoa does in 4 different environments around the country. Here's how it's done when you do different planting patterns or phenotyping at the university itself. So all of these, the individual researcher is able to get his own answers to what he's looking for. But then what we're also doing is now we're also building this database of information about quinoa in Malawi. And in a couple of years, we'll be able to put all this data together and we'll be able to say, okay, now huge database, 20, 30, 50,000 data points, everything you could possibly want to know about quinoa in Malawi. We'll know where it happened, we'll know when it happened, we'll know the environmental context, and we can do this big data analysis that Dave was talking about earlier. We can enhance, again, on-farm research. So Helen Wale and Kareem Lungwe, who are seen here, master's students supported by the McKnight Foundation, and they're using farmer research networks to go out and understand the effects of growing different legumes, different planting patterns, intercropping, groundnut with pigeon pea versus just groundnut versus just pigeon pea, and rotation with maize. And they want to know how this affects real productivity on smallholder farms. So they have these research questions that they want to know. How does farm typology, soil type, resource availability, all these things, and agroecological conditions contribute to the heterogeneity of crop performance? What does all this mean? And how do soil and crop management strategies impact crop production and ultimately food security in these regions of the world? Here's another scientist. Here's Donald Ciani and Ivy Lagoe. They're both doing research with the National Department of Agriculture Research Services, and they want to know how planting patterns of soybean and groundnut affect production. May seem like a simple question, but it can be hugely important to a farmer in the field. They also want to look at these different soil management practices, no-till, basin planting, all different types of ways of managing your soil. How does it affect productivity? So in the last 18 months, and when I was doing the math for this talk, I was quite shocked. Our partners have gotten to 122 farms in Malawi, all over the place. In the northern district in the red, in the central district in the yellow, in the southern district in the green. They've collected over 12,000 data points. This isn't the research station stuff, that's another 30,000 data points. But 12,000 data points of on-farm, what's really going on with plants in their environment. And they're building this huge network, this huge database of what's going on. And as we keep doing this, not only are they answering their local questions, but we're getting a ton of information that people are going to be able to use. In a couple of years, maybe we can start building a feedback mechanism. Somebody could come in and say, okay, I want to build a map where somebody can go to a website and they can say, I live in this district and I have this soil type, and I want to know which crop I should grow, which variety of that crop I should grow, which management practice works best in this area on these farmers. Now we're starting to build this database where we can think about answering those questions and having those types of feedback mechanisms built for farmers. Also, this is my last slide. We're also expanding into working with private industry. Global Seeds is a private seed company, and they go to CGR centers, public centers like CIMMYT or ICRISAT or these organizations. They go and they get public seed varieties, and they go and they grow foundation seed, and then they sell it off to companies who then get it out into the rural areas where farmers have access to it. And so now this is them breaking ground on a number of demonstration trials that are going to be planted within the next couple of weeks. That'll be scattered all over Malawi, where we'll start understanding how these different varieties interact in these different areas. All right, and now, before I lose my voice, I'm not going to read everybody's name, but there's a huge list of scientists and students at Luana and DARS who've done an amazing job, who've worked hard, gone out and collected a ton of data, and made all this possible and allowed us to expand it. And also special thanks to Frank Mtambala for doing so much work and being such a responsive guy and hardworking. And again, special thanks to Ag Bio Research for sponsoring the event. Any questions?
Do you have any plans to expand to other countries within Africa?
Yes. And Dave will be mad at me because I didn't bring that up a few minutes ago. We're working with Legume Innovation Lab to expand into Zambia. And we've got one professor there who's working with his students on bean breeding right now. We also have a number of devices in Uganda where Isaac Dramadri in the back, he went last summer, and then he sent me an email. He was like, hey, people like this, can I leave them here? As long as they'll be used, you can leave them there. And so we've got a number of scientists who are using it that we've never met. The soybean data that Dave was showing at the end, I have no idea who that person is. He's done a really cool project, and he's got really clear results. I've never, helped him out with technical support. Isaac trained him, gave him a device, and he's off and running, which is always fantastic to see. Sure.
Excuse me, I'm not a scientist, so if this appears stupid, just tell me. But the data that you collect from Malawi, can you generalize to other parts of the world, or does it get really specific to the particular environment?
I don't think we have enough data from other places to really tell. As we build up, as we expand to other places, we'll be able to start to see how much they line up, how similar they are, how different they are, and whether or not we can draw conclusions about something in Malawi to, say, Zambia. I don't know. I think we'll have to see as data comes in.
Without multi-spec and photosync, how long would it have taken you to get to where you are now at the level of information that you have?
The crop physiological data, we'd never get there. Most of the researchers we're working with had a tape measure and a scale before. And those are useful, but if you go out and measure what's happening in halfway through the growing season, and then some shock happens, and then you go at the end, you're like, oh, well, this just must be horrible because we didn't get anything. But you don't know it. Well, no, actually, this crop was growing really well, and now you can start to build the context of, no, there's something else going on. And we can see it, where before we would have missed it.
But the actual instrument itself, I know it's relatively young.
With version 1.0, I'm not sure we know. We're hoping for about every 3 years? That it should last 3 years in the field? Okay, we'll talk about that more. As far as the beta units, I'm kind of expecting them to die, but I keep getting quality data from our partners in Malawi. I'm kind of expecting they've been there for 18 months that someday they're just going to be like, we're down. 2 more devices died today, but they keep plugging along. Yep. All right, thank you.